Hess's law. Find delta H of reaction for the following reaction. 3 C solid plus 4 H2 gaseous react to form C3H8 gaseous. Use the following reactions with known delta H's. C3H8 gaseous plus 5 O2 gaseous react to form 3 CO2 gaseous plus 4 H2O gaseous, which has a delta H equal to minus 2043 kilojoules. C solid plus O2 gaseous react to form CO2 gaseous, which has delta H equal to minus 393.5 kilojoules, and 2 H2 gaseous plus O2 gaseous react to form 2 H2O gaseous, for which delta H equals minus 483.6 kilojoules. In this problem and other Hess's law problems, we use the three equations that are given and manipulate them so that when we add them together, we arrive at the reaction of interest. The delta H's will be changed accordingly. Remember, if you reverse a reaction, the sign of delta H is also reversed. If you multiply a reaction by a number, you also multiply the delta H by that same number. So starting with the first reaction, we see we have C3H8 gaseous as a reactant. However, we want it as a product in the equation of note. So we have to reverse this reaction and write it as 3 CO2 gaseous plus 4 H2O gaseous react to form C3H8 gaseous plus 5 O2 gaseous. And because we reverse the reaction from how it was originally written, we have to change the sign from minus 2043 kilojoules to a positive 2043 kilojoules. Now we've used this equation, so we won't use it again. Our next reaction, we see carbon as a reactant. Indeed, we want carbon as a reactant, but we need 3 of it, which means that we need to multiply this equation by 3. So that will be 3 carbons, solid, plus 3 O2 gaseous, reacting to form 3 CO2 gaseous. Because we multiply the equation by 3, we have to multiply the minus 393.5 by 3, which gives us a negative 1181 kilojoules. Okay, so now we've used that equation. Our third equation has 2 hydrogens, but we need 4. So we're going to multiply that equation by 2, giving us 4 H2 gaseous plus 2 O2 gaseous reacting to form 4 H2O gaseous. Again, we need to multiply the minus 483.6 kilojoules by 2 because we multiplied the equation by 2. So delta H for that becomes minus 967.2 kilojoules. So Hess's law basically says that if we can add these three equations together to arrive at the desired equation, then delta H for the desired equation should be the sum of these delta H's. So let's see what we can cancel. We have 3 CO2s on the left and 3 CO2s on the right that cancel. We have 4 waters on the left and 4 waters on the right that cancel. We have a total of 3 and 2 is 5 oxygens on the left and 5 oxygens on the right. So they cancel. And we are left with 3 carbons, solid, plus 4 hydrogens, gaseous, reacting to form C3H8 gaseous. So if we sum these delta H's, that will be the enthalpy of reaction for the desired equation, and that is minus 105 kilojoules.